Bonjour, my name is Thomas. I'm the CTO of Strolid, and today I'll be talking about vCons. If you haven't heard of that before, we'll talk about that today. I'll be talking about their place in the AI pipeline, but mostly we'll be talking about exactly how we at Strolid have been using vCons and AI for our business for the last 10 months. I apologize for not being there in person. We are getting our floors waxed today, and it's quite a job. So if I miss some of you today, my deep apologies. I hope you understand. So today I want to talk about Strolid and vCons, uh, and and I'm going to just introduce this so you understand what we're doing, where we're coming from. So uh, so if we haven't met before, my name is Thomas, and I'm a communications developer. It's been my profession and career and passion. I really enjoyed my life being in the tech and communications market. About 2.5 years ago, I moved over to be the CTO of Strolid, which has nothing to do with technology. At least it didn't. Now it does. And Strolid is a small, privately held company in the automotive space. And our jobs are to answer inbound leads from customers who are interested in buying a car. We work for what's called franchised car dealerships in North America. Dealerships are owned by individuals, not by the manufacturer, and we service all of them. We are a little bit north of Boston, so think about all those great Boston accents. And Strolid has the opportunity to speak with over 150,000 customers every month to help them in their car buying experience. So, as I came to Strolid, we understood that the most important thing that we had at Strolid were the conversations. But one of the things that we found out pretty quickly was there's no conversational standard. I could say conversations were important, but I couldn't use them in a data pipeline. I couldn't use them as a piece of data like I would use anything else. So we proposed the standard called vCons, and it's like a PDF for conversations. It enables the secure sharing of recorded interactions with disparate AI systems. Now, if you've been a fan of TAD Summit, you know that we've came to the market about 2 years ago with TAD Summit with this idea. We've written a white paper for it, and I really appreciate the support of all the people involved in the TAD community. We couldn't have done it without you. And because of your support, we have been able to bring the vCon idea to the IATF, where we have been assigned a working group, and we're currently working on our charter. If you want to be involved in the standards process, or if you want to get to meet some really excellent, really great people, you're allowed to come to the IATF. We'd love to see you. We'll be in Prague in November, and I will be there because I think the floors will be done by then. Now, before I go on to what we do with vCons, I want to tell you about the problem we had at Strolid so you understand the context of what we're doing here. So Strolid, as I said, was an inbound contact center for sales in the automotive space. And the really hard problem is that every last piece of our business is remote. Now, before the pandemic, our staff was in the same place, but since then, they aren't in the same place either. We take care of customers in a couple hundred car stores all across North America. We log into their systems from wherever we are as agents, and our agents span many time zones, not only in North America, but also in Europe. So that is the biggest problem, that our staff is everywhere. We don't even use the same equipment. It's a very difficult problem to see what's happening. It's a visibility problem. And so vCons for us became a really important way for us to be able to visualize and understand what's happening with the 200 businesses that we support, not including ours. So now we have a little bit of a different approach to AI than what you might see in typical conversational AI. So I want to explain that for a minute. So as you may be familiar with conversational AI, chatbots, virtual assistants, the next generation of IVRs, I guess. What they're working on, which is a great thing to work on, is focusing in on making the in-call experience better. So automating customer interactions through chat or voice or someday video, I'm sure, or to reduce expenses by taking the front end of a conversation and automating it before you actually hit a person. This in-call conversational AI, the whispering in the ear, is not what we're working on. There are all kinds of great companies working on that stuff, and God bless you. What we're doing is actually orthogonal to it, and we're working on after the fact. So what we're trying to do at Strolid and what we do with the vCons is we focus in on capturing the conversations after they occur and then using them to gain insight and to basically feed the robots. So vCons are generally thought of as after the fact, after the thing is done. A couple of ways I've heard vCons explained are PDF for conversations. That's a nice one. Eric Lagerway likes the CDR for AI, very telco. That's nice too. And of course, my favorite is the robot food. It was designed to take a human conversation, to give it to automations and AI, and to be able to do it safely. And we'll talk about what that means in a minute. But that's what we mean by how we're approaching AI and how vCons are just a little bit different. So one of the things that we've come to really believe, and I believe it in my heart, is that the conversations between your customers and your agents is a prime spot to observe the entirety of the business. And that's true because the agent and the customer are each displaying both sides of the coin. The customer is a great way to discover how they view your business, and the agent's a great way to understand what the customer wants. That dialogue in the middle and everything it contains really is an interesting and beautiful place to see what's happening in your business in a way you couldn't. And that's one of the reasons we think of this as being like almost like an AI sort of, an X-ray kind of thing. It allows us to see into the black box. It allows us to understand what's happening inside stuff we couldn't normally see. So I just gave a couple examples here from conversations that we've seen at Strolid, and I'll show you how we did this. All of what you're going to see here was built using the vCon standard and an AI framework I'm going to tell you about in a second. Both open standards and both free for your use. And so here's a couple of examples that we've seen. So here's a conversation that happened this morning. Apparently, there is an angry customer who mentions contacting the police and media and threatens to visit the dealership. First of all, I'm a car guy. Please visit the dealership. We can work it out. You're a sale. Please come in. And this is the kind of typical conversation we thought we would see when we started looking for the conversations and trying to understand the insides of a business, and we were right. We see this, but we don't only see this. We see other things too. So for instance, here's a conversation with Mark. And Mark is telling us a lot about himself. He's happy with his car. It's got low mileage. He has no intentions, right? But he's said that when I'm ready, I'm coming to you. Now, this isn't a sale, but this is a relationship. And this is Mark saying, this is what I feel about you. I like you. I like where I'm at, and don't worry, I'll come back to you. Now, so just like every other business, the car store works on customer loyalty and the reduction of churn. Here's something that we can see inside of a business that we couldn't see before, a happy, loyal customer. So that's kind of interesting, actually. Other things we can see. So here's a customer who's claiming that their salesperson is lying to them. So I don't know if you understand the state of the car market here in the North America, but inventory is out of control. It's really hard to get the right car, and when we advertise a car, very often it's gone by the time someone else is there. This is not a lying salesperson. He actually thought the car was going to be there. What does this mean to us? It means that we do not have a good link between what we're advertising and what we have on the lot. This is an uncovered problem that we wouldn't have seen unless we saw, hey, what's going on here? Why is this person so angry? Well, it's because he's thinking there's a car is going to be there, and a car is not going to be there. One of the most interesting things about vCons and robot food is the surprises you have about the things you see. And they happen every day, and they are evergreen. So finally, here's another thing that we didn't expect to see in the conversations, but we do. So here's an example of a technical failure. So I've got an agent who is talking about buying a car from Avis, one of our customers. We love them. And so, but the problem is they've got background noise and they've got call dropping for that call. Well, you know what? This actually ended up in us going back to the agent and finding out why we had bad quality on our side. It doesn't happen all the time, but without things like this, we couldn't see it. These are examples of just being able to see operationally what's happening in the company and using vCons and the customer conversations to surface them. So everything I've shown you so far is real. We've done it. We've been working on this for about 2 years. We've been running the conserver in production since January. I want to show you how we do it. So to give you some ideas of how you could do it, and again, all open source, all open for your work. So we're going to talk about three things. The first thing is, what is the conserver? So the conserver, easily understood, is an AI framework that takes conversations from external systems and then prepares them for consumption, either through redaction or transcription or whatever needs to be done, and then pushes them out on the other side as open and standard data sources. So you can use the exact same data tools you use today, but now use them on human conversations. And then we're going to take a bit of a deep dive into the conserver internals. It's a technical conference where I don't want to rat hole too much, but this is great stuff. I really enjoy this. This is one of my favorite designs I've had a chance to be a part of. The conserver itself is built on two fundamental technologies, Redis and Fast API. And what it does is it allows you to take that framework and that platform that's horizontally scalable and vertically scalable to manage the AI that you need to do for your customer conversations. And then we'll talk about the actual tech stack that we use. What are the tools that we use and how do we create the screens that you've seen? I want to get into that. So let's talk about the conserver, this AI framework for conversations. So this three-step model is usually called an ETL pipeline. It's an extract, transform, and load. And on the very left-hand side here, you'll see that we connect through either APIs where they push information into us from phone systems, video, messaging, anything which contains a human interaction. And what we do at Strolid is we have 5 different systems, and most companies have lots of different systems. We connect to each one, extracting the conversations out from each, and we bring it into the conserver and we protect it. The next step was the extract side. The middle side, the transformation side, transforms that conversation into usable data by us in the business. So it might mean redaction. It always means transcription. Sometimes we do sentiment. And very often we attach other data to the conversation so we know what the conversation was about. Just as a for instance, we're a car company. We almost always put the lead in with the conversation. Why? Because the lead itself tells us a lot about what people are talking about. So the lead is a part of the vCon, and this is where we add the lead to the vCon. The next step, the final step, are the load step, where we save these conversations, we push them out into existing data sources and pipelines. So we'll show you some examples of Slack, of Snowflake, of machine learning, and cloud sharing. I will show you all 3 of them, all 4 of them. And so this allows the data that we get to be great robot food so other systems can use it appropriately. The beginning and end of the conserver and the vCon is to grab conversations, keep them safe, serve them up, and delete them to be compliant to GDPR and customer data protections. In addition, it's a great platform to support data minimization for handling data that goes across security boundaries, etc. So this big thing here is the conserver. Now, I want to talk just for a second, this is probably the more technical of the pieces, about the internals of the conserver. And so the internals of the conserver are really based upon this idea of a chain and a link. So here, let me just go into that for a second. So as I said before, The conserver itself actually has two major pieces of technology that we've put together. The first piece of it is the Fast API, which is a Python framework that allows us to provide an API, which we have, to coordinate the operations of the conserver, to support plugins, to support customization. And it's in Python, which is the dominant AI machine learning language. And that provides us one part of our stack. Another part is Redis. And so this is one of the things I had talked about before, but I want to really emphasize here, is this is meant for any human conversation. And we're really trying to make this available for any scale, small to large. So at the very large ends of the scale issue are high-speed video and high-speed video redaction, which is a very difficult problem. Can you just imagine what it would be for Zoom, for instance, to be able to provide that? It's a lot of work. So Redis allows us a kind of a magic thing in terms of data pipelining. It allows us to not only stack and rack servers, but to be able to keep the data in place so that we can bring the software into the data, work on it there without having to copy every time through. It allows us to manage that a lot better. So a chain is a series of links, and a link is a transformation of a vCon. So you'll see here I have four links. Here, one's called transcription, one's called analyze, one's called storage, and there's a webhook. Now, each one of these links is this group of links, they can all be configured separately, is a chain. And the conserver can support many chains. So if you were to process an inbound vCon using the conserver, maybe we extracted it from FreeSwitch or Twilio, the way it would work deep in the technology is that vCon would be loaded up into Redis, and the vCon ID would be put into a Redis list. And that Redis list is a durable list of messages that could be drained by a chain or multiple chains. Now, those multiple chains are really important because that allows us to have horizontal scaling. You can have one Redis instance for 20 servers all going off the same chain. So that if you want to horizontally scale your platform, it's Redis that allows you to do that, and Redis allows you to do that by having the list be the input for every chain. Now, as it comes into the chain, it goes through a series of links. And the first one here we have is called a transcription link. A couple things to say about that. So the first thing I want to say about that is this transcription link that we're talking about here is one that accepts a vCon ID and then calls deepgram to transcribe that conversation. We've had implementations with a number of vendors, including OpenAI and Whisper. And deepgram is a great partner for us. We want to really thank them for all the help and support. And but this allows you as a AI engineer to pick the transcription engine you'd like to work with, either internally or externally, and to be able to swap them out without being locked into a vendor. The other thing I want to say about this really quickly is this is a great example of how we support vertical scale using the conserver. By using a GPU in the backplane that's hosting the Redis, we're also able to put custom hardware to apply to the processing itself for video processing. So how we would stack a video processing center would be we would have racks of cards, each being off the same Redis list, each card being running on a GPU, just like we would see here in deepgram. Same story with the next link down the chain, analyze. In this case, we would be using an analyzation chain that would take the transcription, ask a question of it. Is the customer angry, or is there mentioning a particular model of car? We can make those calls using the LLM of your choice. We're using OpenAI, but you could use whatever API you'd like to use, or maybe one that's local to you. Now, these two links that I'm pointing at in the middle here, all work off the same Redis key, and that same Redis key is the ID that was being pushed down the chain. And that makes it very loosely coupled as each link works down the chain um, and reduces and allows you to manage the amount of information and data that you have to flow in and out between your algorithms. The next link is a storage link. So what we do is when we see that vCon coming down, because it's all prepared now, we can push it out to 6 different data sources, into an S3 file, to Postgres, to Mongo, and that's automatically done. And then finally, there's a webhook link that can push it out to another conserver for another chain of processing. Maybe it's another part of the network, or maybe I'm in Japan and I'm pushing this to America. Um, and these are the 4 links that make up these chains. We have about 10 or 11 that we've defined for the conserver. You can define your own. Very simple API to use. And at the end, the vCon ID is pushed out to the end of the Redis list to be consumed again. One quick editorial note. Each link can stop the processing just simply by not pushing the ID to the next thing down the line, allowing you to have links that also filter and reduce the vCons that move from left to right. Okay, so how do we do it? So let's talk about that for a quick second. So the first thing I want to just mention, because we've talked about this at TADHack, but I'm sure this will be new to a few of you. This is the vCon standard, the PDF for conversations, and it has 4 parts. The parties that are in the call, the dialogues, the exact recordings of what happened, a running list of the analyses that was done on the dialogues, and a place to put attachments, which are the factual, contextual information that informs the conversation itself. By putting all these 4 things together and putting them into a tamper-proof, signed, and encryptable JSON, we solve several problems in the AI conversation chain. We solve the spoofing problem because we have captured the authority of what we're saying made the recordings. So instead of just having it a WAV file, which could have been made by anybody, we are capturing the fact that this recording was made with these parties, and was then, and after it was made, we can ensure the integrity. The parties itself can tell you not only who was in it, but who said who was in it. So if we're on a Zoom call, it might say Thomas was on it, but Zoom is the authority that said it really was Thomas. The analysis allows us to track which analyses was used by which pieces of AI, solving a really important problem, which is who's got my stuff? Which pieces of the technology's infrastructure have seen my personal details, so I know where it went. It's an important piece. So this is the enabling technology, so I won't spend much more time on that one. But I want to talk about how we've used this in our tech stack at Strolid, how we've been able to put together what you've seen. So here is actually our real tech stack. Here's how we run it. So if you start from the left-hand side here, you'll see here that this is the, we connect to the communication systems at Strolid. And as I said before, we've got 5. Almost all companies have 5. The only companies that don't have 5 are too small, the person in the company, or maybe they're a Genesis customer, but even Genesis customers have many places to go. So we connect to all of our systems using their APIs to withdraw it, or we have systems that push vCons in. Now, as they come into the conserver, that's the place where we are doing chains, and some of our chains push up into Slack, and that's where you saw the Slack information. And some of our chains push up into Elasticsearch. And that allows us to take the conversations that we see as we come through and search. So whatever someone mentioned, whatever time for the last 10 months at Strolid, I can type in, Dalmatian dog, and if someone talked about Dalmatian, that call will come up. The conserver itself then pushes down into 2 different storage units, the S3 bucket, and that S3 bucket is our long-term storage. We keep that for archival reasons. We also push it into a Postgres instance, and that is our operational instance. We use a follower for good network practice, but that Postgres instance is what we drive 2 of our major tools from. One tool is called Hex. Hex is an online worksheet that allows you to quickly make reports using Python and SQL, and so all of our real-time reporting for operational efficiency, etc., is done in Hex. And we also push it out into our own infrastructure so we can have a call log. So sometimes you've seen communication systems with call logs. Strolid has a call log, not just for the communication system, but for everybody. And that's done by aggregating all the communications we see on the left. This Postgres follower is also the source for our long-term reporting, which we push out into Snowflake. And Snowflake is our data warehouse. And then from there, that's how we push the information into our dealers' infrastructure, or we allow them to access it through a dealer portal that's written in plain, JavaScript or Svelte, or for their own analytics purposes by using tools like Tableau. For people in the enterprise, for people who are trying to understand data pipelines, this is pretty standard stuff, but now it contains the customer conversation. So a couple more things before we go. So I talked about Hex. Here's a great example of a Hex sheet that we use all the time. A Hex sheet takes, at this point, about 30 minutes for us to do. And we give it a vCon, and we design this page here. And one of the important things about Hex is it allows us to democratize the data. And I'd like to point out one thing here. This particular conversation that we're talking about, you look on the right here, you see an LLM worksheet and a download link. So the download link allows you to download the vCon locally, and I'll show you that in a second. And the next link, the LLM worksheet, is another Hex sheet, but allows us to take that conversation and give it to a chat bot or an LLM like ChatGPT directly, so that we can use this conversation and ask direct questions of it. So that looks just like this. So one of the most important things that we've seen here at Strolid is that in what we're seeing is in the world of AI and conversations, at least, if not everything, that there are really a lot of smart bots on the top, and there's data on the bottom and nothing in the middle. I mean, not much. And here's an example of what I mean. This is a vCon. Nothing special about the vCon, just a conversation. And I used Claude, which has not been trained on vCons whatsoever. There's no pre-training whatsoever. And what you can do with a vCon is give it to Claude and say, please write an apology letter based on this conversation. And you can see it did a great job. Why? It has all the information it needs. It knows what I was shopping for. It knows my name. It knows the sentiment analysis. It has the transcript. Everything the bot needs to do a great experience, it's right here. And what was that? And so there was the bot, and there was the data, and nothing else. So I think that's going to be a real important thing to keep an eye on as we go forward as an industry about how much is missing from the middle. I think a lot of it's going to be missing, and it's going to be a data game on the bottom and a bot game on the top. So thank you for being with me today. I wish I could have come in today, but if you're around, we're having lunch in the back 40. Please visit. If you want more information about the vCons and the conserver, including the complete source code for everything you see here, including the conserver, please visit us at vcon.dev. I'm so thankful for you to be part of TAD Summit, and it's very dear to me and a lot of us here. And so you're hanging with the right people if that's the kind of thing you want to be looking at. And if you want to get involved in the standards process, I really encourage you to support us here at the IETF. Standards are important. The internet is important, and the people are important. The internet doesn't run by itself, and there's a lot of good work still to be done. So if you're interested, I would love to see, your support and your involvement. So thank you so much.